Overview of size reduction. The principles of size reduction involve various mechanisms and techniques aimed at reducing the size of particles or materials into smaller, more manageable forms. Size reduction is crucial in many industries, including pharmaceuticals, food processing, mine, and materials processing. Here are the key principles of size reduction. Mechanical impact. This principle involves applying mechanical force to break down particles by impacting them against a surface or each other. Examples include impact crushers, hammer mills, and ball mills, where particles are crushed or pulverized by the impact of moving parts or media. Compression. Compression involves applying force to compress materials between two surfaces, resulting in the reduction of particle size. Examples include jaw crushers and cone crushers, where materials are compressed between a fixed and a movable surface. Attrition. Attrition occurs when particles are subjected to rubbing, friction, or abrasion forces, leading to their gradual reduction in size. Attrition is commonly observed in mills such as ball mills and attrition mills, where particles are ground or abraded by moving surfaces or media. Shearing. Shearing involves cutting or tearing materials apart by applying shear forces. Shearing is common in cutting machines, such as shears, shredders, and cutting mills, where materials are sliced or shredded into smaller pieces. Crushing. Crushing is applying compressive forces to break particles apart. This principle is utilized in various crushers, including gyratory crushers, roll crushers, and cone crushers, where materials are crushed by the squeezing action between surfaces. Grinding. Grinding involves reducing materials to particles by frictional forces between particles and grinding media. It is commonly used in mills such as ball mills, rod mills, and grinding mills, where materials are ground by the action of rotating or oscillating media. Fluid energy. Fluid energy size reduction involves using high-velocity jets of gas or air to impact particles, causing them to break apart. This principle is employed in jet mills and fluid energy mills, where materials are pulverized by collisions with gas molecules or particles. Cutting. Cutting involves slicing or shearing materials into smaller pieces using sharp blades or cutting edges. Cutting is observed in various machines, including cutting mills, knife mills, and granulators, where materials are cut into desired shapes or sizes. These principles of size reduction are often combined or utilized in various combinations to achieve desired particle size distribution and properties for specific applications. The choice of size reduction method depends on factors such as the type of material, desired particle size, production capacity, and energy efficiency requirements. Principles of size reduction. 1. Compression. Compression involves applying compressive forces to the material, causing it to deform and break apart. This mechanism is commonly observed in equipment such as jaw crushers, gyratory crushers, and roll crushers. Material is squeezed or compressed between two surfaces, such as a fixed and a movable jaw in a jaw crusher, resulting in its fragmentation. Compression is effective for both brittle and ductile materials. 2. Impact. Impact involves subjecting the material to high-speed impacts or collisions, resulting in its fracture and fragmentation. This mechanism is commonly observed in equipment such as hammer mills, impact crushers, and ball mills. Material is struck by rotating hammers, blades, or balls, causing it to break into smaller particles. Impact is effective for brittle materials but can also be used for ductile materials. 3. Shearing. Shearing involves cutting or tearing materials apart by applying shear forces. This mechanism is commonly observed in equipment such as cutting mills, granulators, and shear shredders. Sharp blades or cutting edges exert shear forces on the material, causing it to fracture and break into smaller particles. Shearing is effective for fibrous or tough materials. 4. Attrition. Attrition involves the gradual reduction in the size of particles through rubbing, friction, or abrasion against each other or the walls of the equipment. This mechanism is commonly observed in equipment such as attrition mills, sand mills, and ball mills. Material is agitated and collides with other particles or the walls of the equipment, resulting in its fragmentation. Attrition is effective for materials that are friable or prone to wear. Various types of size reduction machinery. A ball mill is a grinding machine that uses balls to grind and blend materials into nano-sized particles. A roller mill uses cylindrical rollers to grind or crush materials, such as gravel, ore, grain, and plastic. Other rollers can be used in opposing pairs or against flat plates. A hammer mill, also called a pulverizer, is a machine that uses high-speed hammer blows to grind, crush, and shred material. Cutting mills are mills that use cutting and shearing forces to reduce the size of samples. Comparison of the crushing principle. A crusher mill is a machine that reduces the size of rocks, stones, or ore into smaller pieces so that the material can be processed into finer particles in a grinder. Crusher mills are used in many industries, including mining, iron and steel, and quarrying. Types of crusher: cone crusher, jaw crusher and impact crusher. Factors to consider when choosing a size reduction machine. When choosing a size reduction machine for pharmaceutical applications, several factors need to be considered to ensure that the selected equipment meets the specific requirements of the process and product. Here are some key factors to consider. Particle size requirements. Determine the desired particle size distribution of the final product. Consider the range of particle sizes needed for optimal drug performance, dissolution rate, bioavailability, and formulation characteristics. Material properties. Understand the physical and chemical properties of the materials to be processed, including hardness, friability, moisture content, and thermal sensitivity. Select a size reduction machine compatible with the material properties to achieve efficient and effective particle size reduction without compromising material integrity. Capacity and throughput. Assess the required production capacity and throughput rates based on production demands and processing volumes. Choose a size reduction machine that can handle the desired throughput while maintaining consistent and reliable performance. Processing environment. Consider the processing environment, including space constraints, facility layout, and regulatory requirements. Select a size reduction machine that fits within the available space and meets regulatory standards for pharmaceutical manufacturing, such as good manufacturing practices, GMP, and cleanliness requirements. Process flexibility. Evaluate the versatility and adaptability of the size reduction machine to accommodate different materials, formulations, and processing conditions. Choose equipment with adjustable parameters, interchangeable components, and multiple processing options to meet varying production needs. Ease of maintenance and cleaning. Consider the ease of maintenance, cleaning, and sanitation of the size reduction machine to ensure product quality, hygiene, and compliance with regulatory standards. Select equipment with accessible components, smooth surfaces, and easy disassembly for cleaning and maintenance procedures. Energy efficiency and operating costs. Assess the energy efficiency and operating costs associated with the size reduction machine, including power consumption, maintenance requirements, and spare parts availability. Choose equipment that offers cost-effective operation and optimal energy utilization over the long term. Particle size control and uniformity. Evaluate the precision and control capabilities of the size reduction machine in achieving the desired particle size distribution and uniformity. Consider equipment features such as adjustable settings, multiple millages, and real-time monitoring systems for particle size control. Safety features. Prioritize safety considerations when selecting a size reduction machine, including operator safety, product containment, and hazard mitigation. Choose equipment with safety features such as interlocks, guarding, emergency stop mechanisms, and explosion-proof design as applicable to the processing environment. Supplier reputation and support. Research the reputation, reliability, and technical support services of the equipment supplier or manufacturer. Choose a reputable supplier. Track record of quality products, responsive customer support, and comprehensive after-sales service to ensure a positive user experience and long-term satisfaction. By carefully considering these factors, pharmaceutical manufacturers can select the most suitable size reduction machine for their sick processing needs, ensuring efficient, reliable, and compliant particle size reduction in pharmaceutical production processes. Size reduction comparison table. Number 1. Method compression, suitable material hard brittle, mechanism squeezing and compacting, applications coarse reduction, rocks. Number 2. Method impact, suitable material wide range, mechanism high speed collisions, applications secondary, tertiary crushing. Number 3. Method shearing, suitable material soft or specific shape, mechanism cutting, tearing, applications specific size, shape. Number 4. Method attrition, suitable material finer grinding, mechanism grinding, rubbing, applications finer grinding. Number 5. Method cryogenic grinding, suitable material heat sensitive, mechanism freezing grinding, applications heat sensitive materials. Number 6. Method fluidized bed jet milling, suitable material very fine uniform, mechanism high velocity gas stream, applications ultra fine powders. Disclaimer: this channel does not promote or encourage any illegal activities, and all contents provided by this channel are meant for educational purposes only. Any copyrighted material on these slides is included as fair use for educational purposes only. It will be removed at the request of copyright owners.